Mathematics, Advanced Subsidiary Level, Paper 2, 2023, Part 7. Question number 7. It is given that, and then it's the integral sign, and then it's 0 to a, and then they give you the equation 3x squared minus 4 sin 2x plus cos x integrated to x is equal to 1. Don't forget that, is equal to 1. Where a is a constant, show that a is this. Okay, where will you find it in the y equals mx plus c mathematics textbook? You will find it in chapter 12. And chapter 12 is further integration. And this is integration of trigonomic functions. And what page will you find it? You can look there on page 5 to 6. Look at the tables to see all the integration rules, and then look at example 11. That is going to help you. Okay, but let's start. So let's start. So it's a, it's 0, it's 3x squared minus 4 sin 2x plus cos x dx. Let's first just integrate that. Okay. Now, if I integrate, just remember your rules. So I add 1 and it's 3 and I divide by that 3 also. Minus 4, that's a constant. Now sin 2x, look at the rule, but that becomes minus a half cos 2x. And then cos x becomes sin x. Okay, please memorize that rules. And then it's a and it's 0. Okay, I'm just going to simplify a little bit before I put it in. So x free, so that frees cancel. There it's going to become a positive 2 cos 2x plus sin x. And it's a and 0. Okay, now I'm going to start by doing the substitution. So in the place of x, I'm going to say a to the power of 3 plus 2 cos 2a plus sin a minus, don't just assume it's 0. Okay, be very careful and you will see now why. Substitute it. So 0 to the power 3 plus 2 cos. Okay, I'm going to just write it at the bottom. Sorry, because my space, and I don't want to write in that line. So let's just rather write it here. Minus, so it's 0 to the power of 3 plus 2 cos 2 0 plus sin 0. Okay, now I'm going to simplify. So let's put it to equal. Then we can make the equal again here. So it's a to the power of 3 plus 2 cos 2a plus sin a. And now be careful. So it's minus 0. But now if you press this, you can first leave the bracket. If you're going to say, what is cos 0? Okay, you can even think of the graph. Can you remember the graph starts there? So it's 1. And if you multiply by 2, it's going to be 2. Okay. Okay, the cos graph is going like this. It starts there at 1. Okay. And then plus 0. This one is 0. So be careful not to assume, and if it's even 0, you must still say minus and do that bracket. Okay, so basically, I have now a to the power of 3 plus 2 cos 2a plus sin a minus 2. But now, I'm going to put this, I was just working almost with the left-hand side. And now I'm going to put the left-hand side equals to the right-hand side. So I'm going to put this, so therefore, A3 plus 2 cos 2a plus sin a minus 2, and that will be equal to 1. Okay, and now I can start playing. Now I see A must become the subject there, but it's the A on its own. So leave the A3 on this side, and then say, in this case, just take note. Okay, let's first leave the A3 on this side and take everything to the other side. So if I take everything to the other side, I'm doing an extra step, but I just want to show you. So plus, okay, not plus, but then minus. It's going over. So this is staying on this side, the rest is going over. So 2 cos 2a minus sin a plus 2. So do you see what happened now? It becomes a 3. I'm going to take the cube root now. So it becomes 3. Then it's minus 2 cos 2a minus sin a. Okay. Again, remember in these questions, if they say show, you don't use it. You don't start with it. You end with that answer. And did we end with that answer? Yes. Okay, let's go to the examination report and see if we're correct. So if I go there, question number 7, let's see if it's the next page. Yes. Okay, so question A was moderately answered, although this was a very easy question, straightforward. Candidates showed poor integration skills. You must learn the rules. Okay, the formula sheet will help you, but it will not help you with the ones which is a bit more challenging. It was often, so it's best to memorize the summary in the textbook, make your own summary. It was often seen that negative 4 sin 2x was wrongly integrated. Okay, it must go to that half. Instead of 2 cos 2x, cos x was also often wrongly integrated to negative sin x. Another common mistake was to integrate 1 as well. These candidates did not realize that they needed to apply the boundaries to the integration first, and the result must be equal to 1. So you must first integrate and then you put the left-hand side equal to the right-hand side. Many candidates fail to apply the bottom boundary 0. They presume it's 0. It's not always 0. Not realizing that cos 0 is 1. Because remember the cos graph? It starts there on the top. Okay, so let's just look. There was the integrated. So it seems to me you already got 2 marks there for the integration. And then putting it equal to and then establishing that answer. Okay, so let's go back to the question paper. So if I look, I just want to show you quickly. So if I move it down, I just want to say, okay, so basically, I think if you integrate it correctly, so by just integrate it correctly, I think you will already get your 2. And then putting it and then establishing that last. Okay, but that's just how I think. You can read the report again or even ask your teacher. Okay, let's go to question number B. Using the equation a n minus 1, and then they give you, show by calculation that a is between 1.3 and 1.6. Now, it's as soon as you see they do this, what bell rings in your mind? Where do you think we are now in the mathematics textbook? In the mathematics textbook, y equals mx plus c, we are now at the final chapter, and that is numerical solutions of equations. So that will be chapter 13. Okay. So basically, now I'm just going to, I want to show that it's a root. So what example will help me? If you go there to page 559, example 7. It's there where we do the change of sign. As soon as there's a change of sign, we know that the root is there. Okay. Now, because they don't give you to say the degrees is between this or this, there's no indication, must I be in degrees or must I be in radians? I would say rather always go to radians. And if you read the report, you would say that if you were staying in degrees, you would not see that change of sign. So make sure that you put your calculator on radians. Okay. Now, first, don't forget that you must take this, before you can do this substitution, you must make this equal to 0. So you must take everything to one side. So it's almost like I'm saying fx, and I'm taking everything to one side. So I'm leaving this, okay, this is now what I proved there in the other one, the A. Okay, and I subtract that A, okay, in minus 1. Okay, are you with me? I'm not putting in the ends, I'll put it in as soon as we come to number C. Okay, so basically to show that, they say, show back that there's a root in between there must be a change in sign. So let's start by putting 1.3. Now, according to me, what was a bit challenging in this question is, but it's just that you press it correctly on the calculator. And I'll show you, I think the smart calculators is thinking a lot for you. I have a very old calculator, which I really like working with. And for him, I must sometimes just put a little bit more brackets in. Okay, so I want to press this now on my calculator. Now, can I show you what I'm going to do? I'm going to do it in one step. I'm even going to test it again. But what I will do, I will start with the root, pressing the root on my then I will put a bracket. Then I will also put a bracket there. Are you with? Now, this is not necessary really because you can already know it's 2.6. But then, as soon as I finish with that, I will put a bracket also there. And I will close the bracket there. So that is the brackets that I'm going to put in my calculator. As I said, I have an old one. It's a Casio FZ82MS, but it's just the one I'm used to, and it's doing all the things it must do. Okay, so I'm going to press on my calculator. I must press shift to get to the cube root, and then x free, but on top of it is the cube root. Okay, now I must make sure that my calculator is on radians. Okay, so now I just want to check quickly if my calculator is on radians. Yes, there must be an R. Okay, so I press on my calculator shift, and then I press the x free because then it's the cube root. Then I press an open bracket, then I press 3 minus, and then another open bracket. And then I press 2 multiply cos, but now I press 2.6. 2.6, because I know that will be 1.3 times 2 is 2.6. Okay, now I close that bracket, that inside one there. Then I say minus sin, and now I press 1.3, and now I close that first bracket. Okay, and then I press equal. And then I say minus 1.3 equals. Now I get on my calculator 0.25364654. I just write the full because so that I'm used to writing full calculator displays. Okay, now I will substitute that one. So I do exactly the same. 1.6 Okay, so let's just substitute it there. So it's going to be 3 minus 2 cos 2, 1.6, okay, minus sin 1.6, sorry, I'm looking at the top, 1.6, okay, minus, it's after the root, 1.6. Okay. Again, I'm going to put in my bracket. I will put a bracket there, I will put a bracket there, I will put a bracket. Remember, if you say 1.6 and another 1.6, it's 12, it's 3.2. So remember that you're going to press there 3.2. Okay. And then I close the bracket there. While I'm showing you the brackets, in the next question, we must put it in one step in. Okay, so get used to pressing it in one step. And also just take note that this 1.6, is apart. It's not underneath the root. Okay, so let's start. I press shift, I press x to the power 3. Then I press open bracket. 3 minus another open bracket, that red one. Then I press 2 multiply cos, and remember 3.2, okay, close that bracket, minus sin 1.6. And then close the bracket again, and then equals. And then minus 1.6 equals. And I'm getting, I want to change my color. I'm getting negative, that's the important part, 0.0129938786. Okay, and now I end with a sentence like this. The change of sign indicates the presence of a root between 1.3 and 1.6. Okay, so very important. Just end with establishing that you can show, using the equation that there's a root. So in the exam report, question 7, number B, they say it was extremely poorly answered. The first and most important step before a change in sign can be found is to create an equation equal to 0. So you have to take everything to one side. Candidates had to realize that were values that are this small and there were no negative signs are in radians. Okay, so they wanted you to know that you have to put your calculator in radians. Working in degrees did not result in a change in sign. It's not enough to only find a positive and a negative value. Both values must be seen and the candidates must conclude that there is a change in sign. So you must write that final sentence. Some candidates just substituted 1.3 and 1.6 and concluded that it is a change of sign without calculating the values. So they want, so there's just a typing, you to see the calculating the values. Okay, so make it equal to 0. Then you got that one and you got the negative and there's a change in sign. And that's how you do it. Okay, let's go to the number C part in the question. Okay, so it's building on this previous one. Okay, so in this one, they say now, and now if, say for example, you did not know that it was, if you was, let's just go to, I want to go to the previous. If you did not know that you were doing numerical solutions, chapter 13. As soon as, say you were struggling to recognize that at B, but as soon as you see C, you must, that's what I was supposed to do at B. Okay. Question number C. Use an iterative formula based on the equation in part B. This is very important. I'll take you now to that. To find the value of A correct to 3 decimal places. Use an initial value of 1.45 and give each iteration to 6 significant figures. Okay. Now, it's always that they will tell you to what formula you must use. Now, if you look at question number B, you will see that in the one that they gave you, n plus 1, this is the one in B that you see in B. It's 3 minus 2 cos 2an minus sin an. And there was my 3. That's the one they gave in B. Now, when we wanted to test if there's a root, we took everything to one side and we make it equal to 0. But if we want to find the value that it converts to, then we leave it in this format. We don't take everything to one side. So just take note of that. You can look at the examples and see it in other examples also. You can look at the example on page 555. We are still busy with the same chapter, Numerical Solutions of Equations. And also look at that equations that you see. When they test that it's a root, they take everything to one side. But as soon as they want to see the value that it converts to, then they leave on the left-hand side and on the right-hand side. But look also for me at another example to just see that comparison. You can look on page 565. 565, that example 9. Okay, and just keep it in mind. So I'm just going to use this formula. Okay, now I'm going to start with A1. So the first one, okay, let them start. I'm going to make that A is 1.45. Okay, that's what I'm going to start with. Okay, let's just want to. And then I'll tell you how to press it on your calculator. So A 1.4, that's the first value. Okay, now if I press it in, now before you start pressing it in, press on your calculator 1.45 and then press equals. Are you with me? So 1.45 and then press equal. Okay, now it's saved in. Now I start, and I just as I did in the previous one. Can you remember where did I put my brackets? Now, okay, so before I start, let me first show you where I put in my brackets. Now, I'm going to put, just as the previous one, I put a bracket there. Are you with me? I put a bracket there. But because it's 2a, and I'm not going to, it's in my calculator program, I am going to put a bracket also there. And then I'm also going to put a bracket there. Are you with me? And then I close that bracket, and then I close. So if there's 3 open brackets, there must be 3 close brackets. Okay, and then I can press my equal. But now, okay, let's start. First say 1.45 equals. Now it's in your calculator. Then I'm going for the cube root. So I say shift x3. Now I'm at the cube root. Then I'm going to say, I'm going to open the bracket here. And then I say 3 minus, again another open bracket, 2 multiply cos, another open bracket, 2 multiply, and now I just say answer. Okay, and I close that bracket, and I close the bracket again, this one, do you see? And then I say minus sin, and I say again answer, and I close the third bracket. And what do I get on my calculator? I get 1.58065. Now remember they said to 6 significant figures. So what you can do, can I first show you? I think it's better if you do it like this. 652 849, but then go and make it to 6. 1, 2, 3, 4, 5, 6. So it's going to be 1.58065. Did you see? I wrote the full calculator and then I approximate. Okay. It's always good to do at least 2 or 3, although it converts sometimes very fast, and I think in this example it does, but still, okay. Because now, the only thing that you're going to press now is equal. That's the only thing you're going to press, equal, because it's in your calculator. So it's going to be 1. So for A2, it's going to be 1.58735672, and it's going to approximate to 1, 2, 3, 4, 5, 6. So that is going to become a 6. So it's 1.587336. Okay. And then you press again equal. And I get 1.58727491. And 1, 2, 3, 4, 5, 6. So that's a 4. So it's 1.58727. Are you with me? I think it's already converting, especially if it's to 3 decimal places. So let's just see. If I'm going to convert it now to 3 decimal places, so it's 1, 2, 3. Okay. 1, 2, 3. I think it's starting here. So let's look here. So it's, you can do it with a pencil also. 1 point, this part, 581, 1.587, and here, do you see it's converting? 1.587. So don't forget to conclude by saying, therefore, correct to 3 decimal places. The root converge to 1.587. Very important that you write that little part. Okay, and let's just go to the report and see what the report is saying to us. Okay, so, okay, we are now at the incorrect one, I think, yeah. So this was actually well answered. Both radians as well as degrees gave a solution with 4 steps. It should be noted that every iteration had to be shown to 6 significant figures as requested in this specific question. Every iteration must be shown. Once one is missing, no marks can be awarded. The final answer needed to be clearly stated, and it had to be correct to 3 decimal places. So if you were in radians, did you see there? Okay, so there was our to 6 significant figures, but it converts to 1.587. It's always good to end. But if you were in degrees, you also got your marks for that. So they gave for that 3 marks, so that you show that steps, at least that, and then come to the final answer. So if I must go back just to show that marks, okay, so then it would have been, in this case, it was just the sign. I didn't show here. It was like, I don't think I showed here. Okay, to show this, the change in sign, okay, and then always establish. And then this one, I think at least if they see this 2, and then definitely for the value that it converts to. All these videos refer to the y equals mx plus c textbooks, the #1 mathematics textbook used in Namibian schools. For more information on these textbooks, visit the Straight Line Publishing website. All y equals mx plus c to success textbooks are available in the NEED catalogue of the Ministry of Education. Schools can order these using their yearly budget for textbooks, with the process typically starting mid-year. Make sure your learners have a copy of the Y equals mx+c mathematics textbook used by the top schools in Namibia in front of them in 2025. A final point. If you are in the position, I want to encourage you to buy your own personal copy of the Y equals mx+c mathematics textbook. These textbooks are available at the following bookshops. Remember, success in mathematics comes from hard work, perseverance, and the courage to face challenges head on. Good luck with your final 2024 examination.